both mathematical and philosophical, which would link together a physics, a science of change, with a mathematics, a science of quantity. And that seems to me to be radical and crucial for the construction of new forms of reliable knowledge.
Ibn al-Haytham was born in 965 AD in the southern Iraqi town of Basra, and other scholars regarded him as a prodigy. He shot to scientific fame just after the turn of the first millennium and was an incredibly innovative and brilliant scholar. His reputation as an intellect spread throughout the empire. But it was this reputation that would almost cause him to lose everything when he took up the poisoned chalice of trying to tame one of the world's greatest rivers. There's a wonderful, if suspiciously apocryphal story about how Ibn al-Haytham's career as a scientist was transformed. It concerns the Nile and how, just after the turn of the millennium, Ibn al-Haytham was asked by the ruler of Egypt to find a way of controlling it. Could he prevent its unpredictable and potentially devastating floods and droughts? But it didn't take Ibn al-Haytham long to realize that the Nile was way too large to control. On hearing this, the Caliph flew into a terrible rage and ordered Ibn al-Haytham's execution. Ibn al-Haytham responded by feigning madness. The execution was called off and he was placed under house arrest. There, with time on his hands to contemplate, the story goes, Ibn al-Haytham considered deep and fundamental questions in physics. And he began with a truly enigmatic and universal problem. He asked if the wonderful and entirely mysterious nature of light and vision could be explained by mathematics and geometry. Under house arrest, or perhaps here in the rooms of Al-Azhar University in Cairo, Ibn al-Haytham carried out a series of experiments that created the modern science of optics. I'm with Dr. Al-Bizri, who has carefully studied Ibn al-Haytham's work. He explained that Ibn al-Haytham first considered the Aristotelian explanation for how we see, an explanation that was completely unmathematical. Aristotle argued that when we look at, say, a tree, its essence or form emanates from it, and then mysteriously flows into our eyes.
So if I'm, for instance, now looking at the buildings and the trees on the banks of the Nile, I'm receiving the forms of these buildings and these trees in the eye, abstracted from their matter.
According to Dr. Al-Bizri, Ibn al-Haytham found this idea deeply unsatisfactory. He wanted a mathematical explanation. And looking back at existing Greek writings, he found one, although it was obscure and bizarre. This idea claimed that we see because light rays come out of the eye.
Ultimately, it says that vision occurs by way of the emission from the eye of light that is shaped in the form of a pyramid or a cone.
This cone-shaped beam illuminates what we're looking at and is defined by nice geometric straight lines. It seems Ibn al-Haytham liked this mathematical approach, but immediately spotted its flaws. If we see, he asked, because light comes out of the eye, why does it hurt when you look at a bright object like the sun, but not hurt when you look at something dim? Or at night, can light from our eyes really be lighting up distant objects in the sky? So, in an inspired piece of thinking, Ibn al-Haytham combined the two Greek ideas and defined our modern understanding of light and vision. Light, he said, does travel in straight lines that obey geometric laws, but instead of them coming out of the eye, these rays travel into it.
It is the development of an entirely new theory, and also methodologically, it is the beginnings of mathematizing physics.
What Ibn al-Haytham did was take the principles of geometry with its rules governing straight lines and apply them to the real world. He then designed experiments which would test whether the real world measured up to his mathematics. In about 1020, Ibn al-Haytham published his groundbreaking geometric explanation of light in his Kitab al-Manadhir, or Book of Optics. And what really marks this book out as science is that Ibn al-Haytham carefully justifies his theories with detailed experiments that others can repeat and verify. He starts from first principles to find out how light travels. For his first experiment, Ibn al-Haytham wanted to test the idea that light travels in straight lines. Now, to do this, he took a straight tube on which he'd drawn a straight line down the side and a ruler, again with a straight line down the length of it. And by matching the two together, he was convinced then that the tube was straight. Now, if he uses it to look at an object, in this case a candle, he can see the candle through the tube, which is good evidence that the light is travelling up in a straight line. But just to be sure, he then blocked the end of the tube. And then, by looking at the candle again, of course, he can't see it, because what this does is confirm that the light doesn't travel to his eye via any other route in a curved path outside the tube, proof that light only travels in a straight line. Now, this might sound quite trivial and obvious to us, but Ibn al-Haytham was starting from first principles. Then, through experiment, he extends his light travels in straight lines idea to many other phenomena. He explains how mirrors work by arguing that the angle the ray comes in at is the same as the angle it bounces off at. He explains what we now call refraction, why objects look kinked in a glass of water, arguing that light rays bend when they move from one medium to another. And then he tackles the nature of vision. Ibn al-Haytham wanted to understand how an object makes an image on the retina of the eye. So he built what he believed